Good morning, everybody. Welcome to this webinar about the European Geothermal Innovation Award. We will start in 2 minutes. People are still attending it, so see you in 2 minutes to start that. Thank you. Good morning again. It's my pleasure now to ask Miklos Anting, our president of EJEC, to start the welcome. Miklos.
Yes. Good morning, ladies and gentlemen. I'm Miklos Antic. I am the president of EJEC, the European Geothermal Energy Council, and I'm very pleased to see you all, at least in the virtual space, for this webinar announcing the finalists of the Ruggero Bertani European Geothermal Innovation Award. This award is a recognition for outstanding work which has been done in innovating in geothermal. As you know, innovation is the adrenaline of our industry, and it makes it progressing all the time. We have had this award since many years online, and then lots of projects have been awarded before. This year we have 6 finalists with outstanding projects. It was very difficult because the competition was quite rude, and the jury is composed by scientists and people from the industry and from the geothermal community recognized in their profession. This year's jury is composed by Inga Bere, a professor at the University of Bergen in Norway, by Sandra Kircher from Germany, representing Messe Offenburg, Fausto Battini from Magma Energy from Italy, who is also the ETIP, European Technological Innovation Platform Deep Geothermal President, Javier Osugueya from Spain, who is representing the Renewable Heating and Cooling European Technological Innovation Platform. Well, of course, it have been much pleasant to give this award during the Messe Offenburg and give the floor to the finalists during the Messe Offenburg to present their innovation. But the times we live now constrains us to go ahead in a virtual space as we did last year. I would like to introduce Madame Sandra Kircher, representing Messe Offenburg, to speak a few words about the Messe Offenburg upcoming in June, which is also going to be hosted in a virtual space. Thank you very much. And then you will listen to the 6 finalists introducing a quick project, and then at the end there will be a question and answers. Thank you very much.
Thanks, Miklos. Great to be here today. Challenging times require innovative solutions. And this year's GeoTHERM will be different due to the pandemic, of course. Not only in terms of date, which will be the 24th and 25th June, but also platform-wise. New ways make it happen, that the community can meet each other, get in contact, and exchange ideas in the most personal way ever that can be possible in the digital world. And this starts today with a pre-event of the Ruggero Bertani European Geothermal Innovation Award. Before we take a look at the nominees, I would like to take the opportunity to introduce you to the new digital GeoTHERM, a concept which has its roots in interactivity using your own personal avatar. You have the possibility to walk around the exhibition ground, which is mapped, all the halls, all the fair places, and you can just walk around, meet each other, see each other, and interact together. This also applies for the announcement of the winner of the European Geothermal Innovation Award. During the Digital Congress on 24th, this will be the place where the winner will be announced right after the opening speech. In addition to that, all nominees have also the possibility to present their subjects in the trade fair area where they can interact directly with the participants. And now I would like to give you a sneak peek how this will look like. Therefore, I just have just a second to give you a view on my desktop. I hope you all see this. And now, what is the digital GeoTHERM? The digital GeoTHERM is a combination between trade fair and congress. In this year, in a digital fair, all participants can interact. As you see, yeah?
We cannot see you,
You can see it? Oh, sorry. Okay, just a second. I try it again. Okay, just
now.
a second. Now you can see it. Okay, so I have just to start up again. Sorry. Okay. So GeoTHERM this year is a combination of trade fair and congress. It is a digital event in which everyone can interact with each other. So how does it work? At first, everyone creates his own avatar, putting a picture on it, writing his name on it, and then here you see how a hall can look like. So this is already our area in which we will be. And all avatars in the floor can interact with each other. By clicking on an avatar, you are directly in contact with the other avatars. And of course, not only the visitors as participants can interact with each other. And here is an example how visitors and exhibitors together can interact during the trade fair. So we will be happy to welcome all nominees and visitors at GeoTHERM this year in another way, but I think it's a personal way, and therefore we are happy to welcome you. Thanks. And now I would like to pass over to Philip.
Thank you very much, Sarah, for this presentation. We are waiting to attend this geothermal virtual event this year. So now it's my pleasure to start the presentation and give a floor for a presentation of this innovation award that you're all waiting. You will have first a question, I'm sure, for 1 month. Why you have 6 presentations, normally the 5 nominees? It's because this year, 2 of them had the same ranking. So we need to find a solution, and the solution say, give them the chance to be nominees. And now we will present them. And soon you'll know later this month, in June at GeoTHERM, who is the winner. So the first presentation is from Spain. And I will ask now a presentation from Iceland Technology Center about their innovation on monitoring corrosion in wells. So it's my pleasure now to give the floor.
Consuelo, they are having some technical problems, so maybe it's better if we pass to the second one.
Okay, so my pleasure now is to give the floor to NG Solution and Antea. So from NG we have Dimitri, and from Antea we have Nicola. And so I will make you presenting so this quite interesting innovation, because we speak about a new design for drilling, and which can maybe make geothermal district heating even more competitive, sorry, which is already quite competitive. So let's hear about Dimitri, what have been the innovation from them. The floor is yours.
Hey everyone, so Consuelo, can you give me the control to present the slides? Yeah. Great. So I hope you can see my screen now. So it's our pleasure to be here today. We are pleased to be here. So I'm Dimitri Hemar, representing NG Solutions, and I will talk about our innovation, of course, that we worked on last year with Nicolas Fréchin, representing Antea. So we are talking about the multi-drains technology in France. So an innovative design for deep geothermal development. So if we go back to the beginning, we are in the Paris Basin. As you can see on the left side, we have a cross section showing this basin with different geological layers, interesting for geothermal. So the light blue one is the Dogger Reservoir. And so it's a geothermal field well known in Paris, used since the 70s. You have the main properties on the left, so it's around 1,600 meters depth, with high flow rate between 300 and 350 cubic meters per hour. Temperature ranges between 60 and 80 degrees. And we have in this basin around nearly 50 geothermal plants in operation, nearly 10 megawatts each, used for district heating. One thing to understand with this reservoir, if I manage to change slides. One thing to understand with this reservoir is the heterogeneity of its properties. So if you look at the transmissivity map on the right side, you can see different colors highlighting different transmissivity, and you can see that the west side of Paris has better properties than the east side of Paris. Sorry. The east side of Paris has better properties than the west side of Paris. So it's the same for the temperature as well. So our challenge here was to find a solution to develop a geothermal project in the right cycle that you can see on the left in a city called Vélizy-Villacoublay. So you can see there is no purple dot around this city. That means that there is no much doublet in this area. Actually, the historical doublet in this basin is concentrated in the east side, as you can guess. And so our challenge was to overcome these poor reservoir properties and to make a geothermal project happen for district heating in this area, technically and economically. So I will let now Nicolas present in details our innovation in the next slide.
So good morning. So you can see the next slide. So how did we go about increasing the productivity of the wells in such a geological context that Dimitri presented? As you can see on the left, we drilled 3 legs per well. 2 U-shaped legs were drilled in order to cross several times the producing layers that are mostly located at the top of the reservoir. And in total, around 1,300 meters were drilled in a 50-meter thick reservoir. 2 open-hole sidetracks were achieved. And this whole drilling program was done in 1 run per well. And for that, we used the Archer RSS from Schlumberger, and the planning and the budget were respected. And so what is now the result of this original architecture? To give you an idea, we tested the well after drilling only 1 leg in the reservoir. And then we tested it a second time after doing the full drilling and acidizing program. And we found that the productivity index was multiplied by 5.5 between the 2 test phases. Hence, this technology opened up new perspective around Paris, but also more generally as soon as the geothermal targeted reservoir offers poor properties. Thanks for your attention. If you have any question, I think that we will have at the end of the session.
It's right, indeed, Nicolas. Thank you, Nicolas and Dimitri, for this short presentation. As you know, also you have more details if you go to the website of this Innovation Award. And if you have any question, indeed, you can use the chat or the questions. We'll try to answer as many of them today, but in case it's not possible to answer them, maybe we'll ask the presenter if we can answer that via email later on. Now I will go to the second presentation, but it's not back to Spain because it seems we have a technical problem, but we are staying in France, and I will now give the floor to Sophie Lebout and Vincent Moret about geothermal lithium. So you know these new topics that we need to have more electrification, not only for transport, it means more lithium. How can we have sustainable lithium from geothermal? The floor is yours, Sophie.
Thank you very much. Can you see my screen correctly?
Yes, you and your screen.
Yes, perfect. Thank you everyone. Hello, and today I'm here with Vincent to talk about EGELI project. EGELI stands for European Geothermal Brine Lithium. It's a European collaborative project. And the goal of this project is to supply Europe with lithium, a strategic metals for our lithium-ion battery, especially for the electric vehicle sectors. Eramet has developed a process to extract lithium from salar in Argentina. It's what we call the direct lithium extraction process. It's very different from the conventional process usually used in the salar that is based on natural evaporation of the brine. And the good advantage of this process is that it's possible to adapt the DLE directly on the geothermal plant. And this is the goal of the Eugélie project. So to connect this extraction process directly to the reinjection well on the geothermal site to extract the lithium. We have in our consortium, so Électricité de Strasbourg Géothermie, Vincent is working for this company. They are the resource owner. They have the geothermal plant in Alsace, in France. We also work together with BASF, with manufacturing the active material, that is the tailor-made material to extract lithium in our process, and also with BRGM and IFER to do the resource mapping. We have finally a partner named IFPEN. It's a French entity for petroleum and new energy research center, and we have been collaborating with them for many years for this process development. This project is strongly supported by Europe with a grant of EIT raw material. And what we need to do with this process to adapt it to Alsace. First, it has to be adapted to the brine composition. It is very different from what we can find in Salar. The lithium concentration, for instance, is lower. But we also have advantage. We have lower sulfate content, lower boron content that are some impurities we do not want to have in the final product, the lithium carbonate. But we also have specific components from geothermal brine. And we also have different design criteria to adapt this process. Especially, we need to adapt to the high temperature, 80 degrees, around 80 degrees in the reinjection well, and the high pressure, so 20 bars with CO2 pressure, 6 bars of CO2 pressure. So we will have to connect this direct extraction process to this geothermal well, and by checking that all these characteristics can be managed. And so to speak about also a little bit more about the process, this process uses a tailor-made material. It looks like small noodles, and it's actually a tailor-made material that will selectively extract lithium from the brine, and we will be able to re-inject the brine underground only without lithium. So no modification of the brine besides the lithium extraction. And this material is filled in column in order to be able to process this extraction on a continuous mode. And why we applied to this geothermal award today with Électricité de Strasbourg, it's because we actually did a first pilot campaign. It lasted 3 months between December 2020 and February 2021. And we have extract lithium under pressure with the CO2 pressure at high temperature, with no modification of the brine, and with a very high yield, up to 90% of lithium recovery. So this is why we are very proud to apply to this innovation award today. To our knowledge, this is a first in this domain. Lithium can be easily extracted at atmospheric pressure, but under pressure, using this type of technology, this is a first. And this is for us a first step because we are right now preparing the second pilot campaign of the EGELI project in order to have what we call the industrially scalable pilot test. So we will have all the engineering data to be able to design and plan the performance of the future lithium geothermal plant. So thank you for your attention. Maybe Vincent, you want to add some comment on this presentation, if you want.
I don't know if you hear me. Can you hear me?
Yes, yes.
Okay. No, I think you presented well. So I would like to thank you all for this award, and I hope we will win it. So I let the floor to Philippe now. Thank you, Sophie, for your presentation.
Thank you both, Sophie and Vincent. Indeed, really interesting and quite promising. We have some questions for you, but we will see them later in the Q&A session. So now we are moving to Spain anyway. I don't know if we are able to give the floor to Lorena. If not, we will give the floor to Noel. So Noel Canto Tomi from Spain will present us an innovation about.
Can you see the presentation?
Yes, we can see the presentation
Okay.
about how geothermal can help the transition in coal region. So thank you, Noel, and we are giving you.
Okay. Okay. Good morning, everybody. My speech addresses the issue of the geothermal project Barredo Colliery district heating, one of the geothermal projects that we have developed using mine water, and the one that has been nominated for this award. Before going in detail, I would like to give you a brief outline of our company. UNOSA is a coal mining company located in Asturias in the north of Spain. Sorry. And from the beginning, UNOSA has been focused on coal extraction as well as electricity production. Nowadays, and after a long process of reduction in the number of mines and unemployment, UNOSA is trying to diversify into different things, such as renewable energy, especially geothermal projects using mine water. We started with geothermal projects because we wanted to look for a use for those mines that were not in operation and were flooded. When a mine is closed and flooded, we still need to pump water to keep the water table in order not to damage buildings or infrastructure. That's why we have everlasting costs for us. Geothermal projects are a source of income that helps to offset pumping expenses. At the same time, we harness a resource, the mine water, that before it was considered as a problem, as a waste product. We also provide new life for mining facilities, and we collaborate to develop renewable energies and to create new jobs. The first geothermal projects started to be in operation in 2014, and they harness the heat of the mine water, which temperature is 23 degrees. This mine water is pumped from Barredo Colliery, a mine that is located in a town in the central part of Asturias, in the mining area. Later on, we decided to make the most of the mine water pumped from Barredo Colliery and extend the geothermal facilities. But this time, we carry out a district heating, Barredo district heating, that has been in operation since last year. And with the same philosophy, we are now finishing the construction of a new one, Fondón district heating, linked to another mine that is not far away from the Barredo Colliery. The table shows the installed power and the energy supply annually in each group of facilities. In this picture, you can see the spatial distribution of the first geothermal facilities and the Barreiro district heating, as well as the characteristics of the mine. So Barreiro district heating provides energy, heating and preheating of domestic hot water to a secondary school, to the main building of the University of Oviedo in Mieres, and 2 residential buildings. In total, we provide around 2.6 megawatt-hours per year, with a reduction of CO2 emissions close to 700 pounds per year. It's worth mentioning that the electricity that the district heating uses come from a renewable source. It is 100% renewable. And in terms of the cost of energy, we give more than 10% of saving to our clients. So in this diagram, summarizes how the district heating works. We pump the water from the mine, and before going to the river, it passes through a heat exchanger. And in this way, we transfer the heat to a closed circuit of clean water, the evaporator circuit. And there is another circuit, the condenser circuit, and 2 heat pumps connected in series. With the system, we are able to raise the temperature of the water that goes to the different buildings. You can see there are 3 lines, 2 high temperature that reach the secondary school and the university building, and the other one of low temperature that goes to the residential buildings. So just to finish my presentation, I would like to mention that Barreiro Corridor district heating was awarded by the International Energy Agency in 2019 in the category of emerging markets, as well as it was selected for a report by the European Commission in relation to district heating systems. And I hope that I can say in the next presentation that it was also awarded with the Ruggero Bertani European Geothermal Innovation Award. So that's all. Thank you very much for your attention, and good luck to everybody.
Thank you very much, Noel, for your presentation, and a really good project indeed. Thank you. And let's see who will win this award this year. Now we will fly to Sweden, and I will give the floor to Hilary from Megawatt Solutions to show a new solution in heat pumps. So the new integrated heat pump solution. Hilary, the floor is yours.
Good morning. We had some muting issues. It's a great honor for us to be here today presenting our geothermal technology to our distinguished jury members and esteemed colleagues from other European countries. Megawatt Solutions Nordic AB, hereinafter referred to as Megawatt Solutions, is a leading Swedish geoenergy technology company that was founded in 2016. Our geoenergy district heating solutions have been installed in our customer sites and in full operation since 2019. According to the Swedish Energy Agency in 2020, currently more than 50% of Swedish single-family houses have an installed heat pump, which is more than any other nation in the world. This generating carbon-free energy valued to more than 25 billion Swedish krona per year. As the share of renewable energy, such as solar and wind power, continues to grow, the heat pump solutions have increasingly become customer favorites for their high coefficient performance and financial outcomes, their low life cycle cost, as well as the carbon-free environmental benefits. Our main energy product, trademarked as the e-box, is a megawatt level prefabricated energy station in a standard 20-foot container using a ground source heat pump solution, hereinafter referred to as the e-box. We can satisfy up to 100% energy needs for large residential or commercial properties by providing heating, cooling, and hot water with our carbon-free energy solutions. Megawatt Solutions has a collaboration with different universities, such as the Swedish Royal Institute of Technology. We're constantly striving to open up new avenues for design and innovation, which would result in a drastic reduction of buildings' energy consumption and carbon emissions. So our e-box was designed based on the following functions that I'm going to explain on the following slides: mission critical reliability, megawatt capacity, rationalization, industrialization, digitalization, both heating and cooling. Mission critical reliability. Our e-box has an uptime of 99.6%. This ensures the stable district heating operation, and we achieve this by our unique Lego-style modular design. Each e-box contains 4 to 8 of our own tailor-designed heat pumps. Multiple e-boxes can be connected together to form a large energy station used as a district heating cluster. Such installation can be extended based on further development in the area. Megawatt capacity. Our large capacity provides district heating by using geoenergy solutions instead of traditional combustion-based heating solutions. The Lego-style modular design offers scalability of the system. More modules can easily be added later based on customers' increased energy needs. Such design also provides flexibility, as individual parts can be quickly added or replaced. This is extremely important for the maintenance and service of the energy system. For example, a compressor can be replaced in a matter of hours without shutting down the system. So we provide a stable, consistently reliable energy system without interruption. Rationalization. We have rationalized the traditional manual labor process and found ways to drastically reduce the installation time. A traditional process could take up to 18 months, and it's now done in a few weeks. Industrialization. Like the housing industry, most of our installations are pre-manufactured in a Swedish factory, where they're also tested and quality assured. This ensures our plug-and-play feature for high-quality, fast, hazard-free, environmental-friendly project implementation. We provide cooling in the summer and heating in the winter. Digitalization. We connect all the sensors from our e-box energy systems, customers' IoT devices, and their BMS into a cloud-based SCADA system. Our open API facilitates easy connectivity to customers' existing IT systems and BMS. Real-time data is sent to authorized engineers and property managers from anywhere at any time. This allows top leaders, property managers, and engineers to make data-driven decisions on preventative management instead of reactive management, improving property financial performance, the energy production, and on smart building control to avoid wasteful habitual behaviors. Outdoor e-box. During the COVID-19 pandemic, under tough public health restrictions, our outdoor design has proven to be hugely beneficial by allowing our engineers to have free access to the energy stations, and has thus ensured continuous service in our customers' properties. Another benefit of the outdoor design is that it frees up space within the building itself, and the e-box could even be used as a charging station for electric vehicles. So, the carbon-free hybrid GSHP PVT e-box solution. As part of our ongoing R&D with KTH, we have launched a new generation of e-box solutions by combining GSHP with PVT. The new solar hybrid e-box is completely carbon-free energy solution. It reduces borehole depth or decreases borehole space while keeping a similar or higher performance level. It adds increased COOP due to the thermal gains from the PVT. The e-box electricity consumption is covered partially or fully by the PV generated electricity, and the efficiency increases the efficiency of the PV panels due to the cooling of the heat transfer fluid circulation system. A standardized solution for decarbonisation. The e-box presents a unique opportunity to hasten the path towards decarbonisation. The prefabricated e-box is ready to be shipped on demand all over the world, hence the standard 20-foot design in a container. Sweden has an ambitious goal of building a low-carbon society, which including a target of cutting greenhouse emissions by 59% by 2030 2030 compared to 2005 and achieve a net zero carbon economy by 2045, according to the IEA. This requires rapid adoption and deployment of resource-efficient energy solutions, which are adjusted for design, integration, control, optimization, and industrialized production. Our e-box has been created for these purposes. Megawatt Solutions e-box is a carbon-free alternative for replacing fossil fuels and combustion-based heating. It can be applied to large properties, commercial buildings, warehouses, logistics centres, and for replacing small and medium-sized energy centres in district heating networks. Thank you very much for listening to our presentation. It's such an honour. All the best.
Thank you very much, Hilary, for your presentation, and let's see if it was the one chosen for being the winner. But that we'll know in 1 month, and before to know that, we have a last presentation. And as you can see, in geothermal, innovation is going from the equipment. We have seen the heat pump. From the drilling, we have seen a new well design. From new opportunities, lithium extraction. But we see that also geothermal is going beyond. And now I will give the floor to Alma from ON Power in Iceland and see how geothermal is providing a lot of things more than energy. So Alma, the floor is yours.
Yes. Good morning. I hope you can see my screen. I don't know.
We see you, we hear you, but the screen is blue for a moment.
It's blue. How about now?
It's perfect. Just in full mode, and it will
fix this. Close it. Okay. There's something. Let me see. I'm gonna change the settings. Great to have it live. Let me see. You can see my presentation, right?
Yes, we can see it, but not in full screen mode.
Okay. Sorry about that. Good morning. My name is Hjálmar. I'm manager of business development at On Power here in Iceland. Today, I'm going to present to you our green innovation at On Power's geothermal park. The geothermal park is located only 500 meters from Hellisheiði geothermal combined heat and power plant in Iceland. It's one of the largest geothermal plants worldwide. The vision of the park is to utilize better the geothermal resource, support innovation, and create value from waste by offering the following input streams to other businesses. We offer, of course, electricity, cold water, heat from various sources such as a high pressure steam, low pressure steam, and geothermal water or waste heat from power plant operations. We also offer geothermal water and its mineral content, which is rich in silica. Carbon dioxide, On Power is currently looking into the feasibility to further isolate the CO2 from other geothermal gases. And lastly, CarbFix is our sister company that offers services for the geothermal park for permanent mineralization of CO2 from point or ambient sources. Let's take a better look at the two ongoing projects that highlight the innovation taking place at the park today. Climeworks is our newest customer in the geothermal park. The company is a global leader in capturing carbon dioxide directly from the air. Climeworks uses waste heat in the geothermal water from Hellisheiði power plant during low demand for district heat. The company also uses cold fresh water and electricity from On Power, and our sister company CarbFix offers them permanent storage of carbon dioxide by turning it into stone in the basaltic bedrock surrounding the geothermal park. Successful and innovative cooperation and synergy of companies can truly make a difference in tackling global challenges such as sustainability, resource efficiency, and the climate crisis. The second project, On Power, is also taking a part in a European Union supported project called Hydrogen Mobility Europe, alongside the oil company Skellingur. In 2020, On Power started producing green hydrogen via electrolysis of water in a geothermal park by using electricity from Hellisheiði power plant. Intermittent electricity production from wind and solar has been seen as optimal for green hydrogen production. However, stable baseload power from geothermal plants poses a challenge when serving an electricity market where the demand changes considerably from day and night. The green hydrogen at the geothermal park is produced during off-peak hours and distributed to vehicle transportation in the capital region of Reykjavik. This is our mindset of constant improvements, responsible utilization of the geothermal resource, and innovative thinking can lead to solutions that maximize value and minimizes waste. As you can see here on the screen, we produce baseload power. During the day, the energy is used by the consumers, and during the night or the off-peak hours, we use the excess energy to produce hydrogen. Yes, thank you.
Thank you very much, Almar, for this presentation. But yeah, we'll see the question. My question now is that we provide electricity, heating, cooling, water, lithium. We provide energy also for coal mines in transitions. Where will stop geothermal? It's why we call that the decade, because we'll see in the next 10 years that this innovation will help to develop a lot of the market. It's a pity we were not able to connect with the other Spanish company, Ayman Technology Center, but they are also in the nominees, and their innovation is a novel electrochemical-based sensor designed to monitor corrosion in wells and pipes in real time and without the need of inspection. So it was really an interesting innovation. It's why it's in the 6 nominees, and if you want more information, you can find in the website. Now we have time for a family photo, so can I ask all the presenters to switch on again their webcam? And with that also, we start the question and answer session. So we have some questions for Nicola and Dimitri from the first presentation. Quite some questions. So for Nicola Frechin, you mentioned a 5.5 index, just in order to understand the specific contribution of the additional legs. What would have been the index for one leg plus stimulation?
Yeah, it's difficult to answer with 100% variability, but in this type of context for Dogger reservoir, we used to double the productivity. I mean, if acidizing works well, we can double the productivity index thanks to acidizing.
Okay, we have another question. I don't know if it's Dimitri or Nicola for the first presentation. It was, what was the reservoir? Were you stimulating carbonate?
What was the reservoir? This is the question?
Yes.
I mean, the reservoir was like the Dogger reservoir, so as we said before. So we were targeting these oolitic carbonates, and as Nicolas said before, of course we use some acids as well to develop the the wells and the productivity, and just to talk about the multiple legs. So the idea was to cross multiple times this carbonates, productive carbonates, in order to increase the productivity, and that's it.
Okay, thank you, both of you. For EGLI projects, the question is, so you speak about another plant from September, and what will be the next step after September?
Yes, good question. We are preparing the after. But first, what we need to do through this EGLI project is this technical proof, this technical feasibility study, as well as the economical feasibility study. So that's what we are busy at the moment to see what are the synergy between geothermal plant and lithium plant in terms of utilities and so on to enhance the business case and to find the best profitability for this business case. And the next step will be to push further this technology validation and this business case also validation by doing some pilot campaign longer with more volumes in order to have more lithium carbonate production at the end, and to do the commercial qualification of the product through end users such as BASF, for instance.
Okay, thank you, Sophie. Now we move to UNOSA, to Noel, and we have a question. Is cooling down the water disposal could be seen as an additional improvement of a former situation, isn't it?
The cooling of the water?
Cooling down the water disposal, yeah.
So we provide also cooling. I don't know if this is what you mean. We provide as part, besides heating, we provide cooling to different buildings, and we use the same water, the same mine water, in order to dissipate the energy, the heat, into the mine water. So we improve the efficiency of the facility in that way. This is what we are doing to provide energy, for instance, to a hospital that is in the town of Mieres, and it increases the efficiency very much.
Okay, thank you, Noel. And we have just a new question back to EGLI, to Sophie and Vincent. Is how many lithium do you expect per year and per power plant? Of course, the question that we all have.
Good question. Yeah, that's part of the business case study. If you take one plant like the Rittershofen plant, the flow rate is around 300 cubic meter per hour. And the base case of what we are studying in the EGLI project would be the double. So 600 cubic meters per hour, and that will lead to lithium carbonate production of almost 4,000 tons per year.
Okay, thank you. I hope you take note of that, because we will see the challenge for next year if it's right or not. Okay, now to Megawatt Solution, to Hilary. So you propose this new heat pump innovative box. What you have in mind in terms of marketing development? So how you will develop?
Yeah, thank you for the question. Yeah, so the e-box is really designed. I mean, heat pump usage in Sweden, ground source heat pump, is very widespread, as we said, and we really see that the e-box can present an opportunity to replace district heating, especially when it combined with this PVT solution. So that is really the view, to use the e-box in combination with this to offer district heating replacement.
Okay, thank you, Hilary. And now I think it's the last question to the last presenter, to Almar. So you mentioned hydrogen, but are you seeing that as a real opportunity for the demand for hydrogen in Iceland?
Yeah, today we have some hydrogen cars that are using the hydrogen, but we are also looking into exporting them to Europe. So it's a small electrolyzer. It's 750 kilowatt. So we're not producing a lot, but we're producing it at off-peak hours, and it is used today in our transportation vehicle that uses hydrogen.
Okay, thank you, Alma. And now, as we are about to conclude, we are back to the first presentation, because it seems that our Spanish colleague has been able to connect. So we will try to give her the floor for a short presentation. Are we able, Lorena, to hear you?
Can you hear me? Hello?
Yes, we can hear you.
Yes.
Fantastic. So you have a floor now for a short
Thank you so much. Okay, so I need to share my presentation. I don't know how to share it.
We will help you to manage that.
Yeah, please.
Lorena, now we see your screen, eh? So if your presentation, we will see it, yes.
But I can see it.
Perfect, open it and we will see it.
Okay, so now it's okay, I think. Yeah, it's okay.
Yes, the floor is yours.
Thank you. Good morning to everybody, and of course, sorry for all these problems with the connections. We have a lot of problems with this application. I don't know why, but first of all, I want to thank you the nomination for the award, and of course, the organization of these types of events that allow us to show our work. Let me introduce IMEM. For those who don't know, IMEM is an innovation and technology center highly specialized in research and sorry, I cannot see. Highly specialized in research of advanced materials and advanced manufacturing technologies. You can see in the slides some numbers to describe our company. IMEM is a small and private center which develop activities in different fields of R&D. For instance, joining technologies, essentially laser technologies, advanced materials, industrial robotics and automation, and environmental technologies also. We are located in the northwest of Spain, in Galicia, very near to the border of Portugal, and we have also small offices in other locations of Spain. In the different units of IMEM, we have an area dedicated to the development of materials, and of course, we also study the durability of these materials. We try to investigate on technologies and on new methodologies to increase the life service of materials exposed to harsh environments. This is the case of the geothermal plants. The key issues limiting the life of operational materials in geothermal plants are mainly corrosion and scaling, as you know. The combination of the chemical composition of the brines together with the temperature and pressure increase the corrosion rate and the deposition of material, and of course promote a high mechanical degradation. All these events provoke serious problems in the installations, as no scheduled outage or reduced efficiency of the plants. So in this scenario, IMEM proposed the integration and demonstration of a new monitoring technology to decrease the risk associated to the corrosion damages. and an in situ and online monitoring of the corrosion and scaling degradation to follow continuously the state of the piping in near real time. Sorry, but for this purpose, Almen design, manufacture, tested, install, and validate a corrosion monitoring system in the frame of a European project called Matching that finished 2 years ago. The corrosion monitoring system is, as you can see in the slide, has this conceptual design. Is composed by different sectors or different sections of the material, the same material of the piping, where the corrosion monitoring system will be applied, or alternative materials as coatings or another metals that you can compare in operational conditions in order to study their corrosion performance. This design is adapted to the requirements, materials, and dimensions of the piping system of the geothermal plant, and can be easily connected by conventional flange to the rest of the installation. In particular, this system was validated in a geothermal plant located in Belgium. Of course, this type of system is not only this monitorized section. There are additional elements in order to register and collect the data obtained from these monitorized pipes. So the main technique to follow the corrosion behavior of these materials is the electrochemical impedance spectroscopy. So we need an equipment to register this type of measurements, and this is a potentiostat that will be connected to this probe. Moreover, we need a PC and a control software that Aymen developed. We obtain by internet the results from the corrosion behavior of this material remotely. So from Aymen, we collect all the data periodically about the behavior of these materials in real conditions in form of Nyquist plots, which is this type of plot that you can see in the slide. From these graphs, we obtain by numerical analysis important parameter that is polarization resistance, that is directly proportional to the corrosion rate of the material. So analyzing and interpreting this data, we can estimate the corrosion behavior of the materials exposed in this monitorized section of the piping system. Of course, Aymen can, in this way, notify and alert to the geothermal plant if there is any risk of failure due to corrosion or to scaling, and we can prevent serious damage in the installation with time. And finally, I'd like just to end, I'd like to highlight the different characteristics or advantages of the system in base of these 6 pillars: a field of application, reliability, originality, innovation, reduction of emissions, and improvements in energy outputs. As you know, the corrosion and scaling are a phenomena that can occur not only in the geothermal plants, but also in other plants exposed to these conditions. So this corrosion system can be applied in other fields, in other sectors as petrochemical or chemical industry. In terms of originality, as you know, corrosion and scaling in wells or pipes are difficult to detect visually or to monitor continuously. So this innovative system will use non-standard methods for in situ or for online monitoring of corrosion. In terms of reliability, Aymen improved can capture every tiny change and it indicates corrosion of the actual pipe in near real time. Regarding innovation, the high sensitivity of the impedance spectroscopy allows to identify change or corrosion or defects in the material long before any visible damages occurs, so we can prevent future damages in the plant. And finally, the use of this monitoring system can prevent this serious failure in the installation, selecting the best materials performing for its operating conditions and promotes in this way an increase of the energy efficiency and in consequence reduction of the CO2 emissions. And this is all from IMEN's side. Thank you again for the opportunity and sorry for the bad connection with the problems with internet. Sorry.
No problem, Lorena. It was just in time before we closed the event. So you are
just
perfect.
In the limit. Just in the limit.
It's really interesting to hear also from you because it's quite an interesting innovation for geothermal. And we know the issue we have with corrosion. With this last presentation, now it's my pleasure to give the floor to Miklo Santic again, our president, to conclude.
Yeah.
Floor is yours.
Well, ladies and gentlemen, it was really a great pleasure to hear your presentations and congratulate you for all your efforts during these difficult times in continuing and innovating on all spectrums of geothermal development, from drilling and completion to utilization and also operation and maintenance. Well, we have touched, I think, all the spectrums of geothermal energy, from multi-usage, from shallow to deep, and I encourage the whole geothermal community to be bold and daring to innovate and push this industry ahead in order to achieve the main goals of decarbonization of heating and cooling in Europe. Our work and the work of the community will be certainly respected, and it will be put into good value for all the citizens of Europe. Thank you very much, and I wish you good luck in implementing all of your projects. That's it.